All right. Hey, adventurers, and welcome to episode 2 of Floor 11. In the first video, we wrote hash key, a name mapped to a number, bucket index, the number mapped to a slot, and the basic body of insert. We compute the slot, push back, increment the count. Self test whispered to us that phase 1 is green. Our buckets shows the 15 monsters scattered with at least one collision. Phases 2 through 5 still fail at this point, and 3 of those are going to be today's work. First of all, we're going to finish insert. We're going to have the duplicate check. Reinserting a name updates in place and returns false, so there's no double count. We're going to work on find, which allows us to compute the bucket, scan only that one chain, compare the name, return a reference to the monster or null pointer, and then erase, which removes only the matching item from its chain. Um, and then we have a provided chain erase first, which does the list surgery. So really 2 beats carry the day today. First, find is the floor's punchline made operational. Floor 1 walked all 15 records. Floor 10 walked a whole balanced tree. And find walks one short chain. Now, the main thing here is just to understand, put that contrast in your mind here. Okay. So let's go ahead and let's get on over here into our hash table header function, and it's time for us to get to work. So let's go down here and find our insert here. Now, where we ended last time, right, we're getting our index here. We're then going back at the index, pushing back the monster name, incrementing the count, and moving on. So that's cool and all, but what we want to do is above our pushback, we want to add in the duplication check. So I'm going to say for monster existing through the buckets at I want to check to say if the existing dot name is equivalent to the m dot name, existing equals m. So essentially what this is going to do is we're just going to update in place here. And then otherwise, we will say, and then right here within the if statement, looks like screen got a little darker there on me. I need to plug in my laptop here soon. We'll also say return false. We did not add a new item. And then we'll keep, of course, our buckets I, pushback in, plus count, return true, all the same there. So really, we just want to add this little block here with the for loop and the if branch. So Monday's insert just pushed. So the same name twice gave you that name twice. A map never does that, and neither should we. So before we push, we scan the home buckets chain. For each monster already in there, if its name equals the new name, we've got to duplicate it. So we update it in place. Existing equals M overwrites the old record with the new one and return false because we did not add a new item. So count must not move. If we get all the way through the chain without a match, it's genuinely new. We push back and bump count and then return true. 2 notes here. The loop variable is monster ampersand existing, a non-const reference because we need to be able to override it in place. And see how cheap this is. We only scan one bucket's chain, not the whole table, because if the name were here at all, it would be in this bucket. That's the same insight find is about to use. Okay. Now, let's go ahead and go to find here. So we need to actually move, in this case, to bestiary slash search.cpp. And let's go ahead and scroll on to our, or right here, actually, it's right here top, our linear search here, just to take a look at this. Before we write find, let's look at what finding a name used to cost for us. In floor 1, we walked every record in the bestiary, comparing until we hit it or fall off the end. 15 records here, a million in a real data set. You look at all of them. Floor 10's recall was better, a balanced tree descent at log of n steps. But watch what it becomes when you can compute the bucket. Let's go back to the hash table now. Okay, so let's go down to our find stub here, and let's add in. Let's check my battery here real quick. Okay, 19, that's not bad. All right, so we're going to say standard size ti equals bucket index of name. We'll go through, say, for const monster m through buckets of I. We're then going to open up our loop. I'm going to say if m dot name is equivalent to name, we'll return back ampersand m. Otherwise, we'll return null pointer. Okay, so what are we saying right here? Well, we compute the bucket. We have one bucket index call, no comparisons, straight to the slot. Then we scan only that one chain. For each monster in this bucket, if the name matches, we return back its address. If the chain runs out, the name isn't here, therefore we return null pointer. That's the entire floor 1 scan, except instead of all 15 records, we look at the handful that landed in this one bucket. On average, that's going to be 1 or 2. That's the big O of 1, or that constant average. It's not zero work, but a fixed small amount, no matter how big the table gets. Now, the part that makes it correct, and it's phase 4, in our test, 2 different names can collide into the same bucket. So you cannot just go to the bucket and return whatever's first. You have to compare the name. If m.name equals name. Now, if we land in the Goblin and Wraith shared bucket looking for Wraith, and we have to walk past Goblin to get to the right one, returning the first item is the bug of this floor, and it's the thing you got to look out for. It's const, by the way, take note of that. Finding does not change anything. Now, let's go down to our erase. Right? Remove one item. We don't want to remove the whole bucket, though. So for erase, we're going to say standard size ti equals, calculate our bucket index for that name. And we'll say, okay, bool removed equals buckets I dot erase first. We'll pass in here, we're going to say ampersand const monster m return m.name equals name. Should have bracket, parentheses, semicolon. If removed, decrement the count, as such. Okay, so what's going on here? Well, erase is the same opening move. We compute the bucket, and then we lean on a provided helper that comes in this floor, because this floor's lesson is hashing, not pointer surgery. Your chain comes with erase first. We hand it a predicate, and it removes the first node that matches and tells you whether it found one. So we pass a little lambda, in this case. We say, is this monster's name the name I want? And erase first walks the chain, unhooks the matching node, and returns true or false. Only if something was actually removed do we decrement count. The thing to drive home here, and it's phase 5, erase removes one item, not the whole bucket. If Goblin and Wraith share a niche, and you banish Goblin, Wraith must still be there. You're pulling one plate off a shelf, not knocking the shelf over, okay? Okay, so let's go ahead and let's build our executable here real quick. Apologize for being kind of slow here. It's not very good. Okay, one thing, this function needs to return something. When I built it, we need to return removed here at the end. And sorry, somebody's vacuuming, so I apologize if you can still hear some of the noise here. But we're almost done, so we're going to try to knock this out here real quick. So we just say here, in this case, self-test whispers. And you see now we have quite a few. done. In this case, phases 2 through 5 are green. Phase 2, find, returns Wraith's record. Phase 3, reinserting Lich, updates in place and the size stays 5. Phase 4, the important one, find returns null pointer for an absent name, even when its bucket is full of colliding neighbors, and still finds the present ones. It's comparing names, not buckets. Phase 5, erase removed Wisp and left Wraith and Lich alone. Only phase 6, which is the rehash, is left for Friday. And now we can do some more stuff with our catalog here. So I can say Whisper Lich. You see here, it's found in one bucket. Great. I can say Whisper Drake. The Hall of Names has no answer for Drake. So in this case, the Whisper Lich, we get the whole record found by computing one bucket and scanning one short chain. No verb collision this floor, by the way. Whisper is find, banish is erased, fresh commands, nothing being shadowed here. And for Whisper's Drake, we get a null pointer, okay? And then, of course, we could then banish the goblin, and I could try to whisper to the goblin, and you see we don't get its reply, okay? And then, of course, we can run buckets. You see here, get our monsters here. We get 14 monsters. So we see here we get our buckets spread out here. And Goblin was pulled off the chain. You see it's not present here. Okay. And so this is the great thing here. We're not breaking anything by removing. We still get to keep the buckets. Nothing tumbles down here. Okay. And that is the exciting thing. Now, of course, I could also recall the goblin. Okay, and I could say buckets. Okay. Now, in this case, okay, so we see here that you notice that once you recall it, you see it's recalled from the tree, but buckets, it's not there. So remember, recall goblin is floor 9's BST command untouched, and goblin is still there. That's not a bug. You banish goblin from the hash table and the hash table only. The bag, the BST, the registry, there's 3 other indexes over the same monsters, and they never heard about it, okay? Last floor, you learned 3 views can diverge. Now it's 4, okay? So if you banish a beast and then see it in list or recall, don't think something's broke. This is the answer. You have 4 tools, 1 source, and they're free to disagree after you change one of them. Okay, so I hope this was helpful, okay? And once again, just noticing we're kind of up to the point now. We just really have a little bit left to go here to get this done, okay? I hope this was helpful, and I will see you in the last video. Apologize if there's any noise from the vacuum in there in the background. Talk to you soon. Bye-bye.